Welcome to all. In this session, we will deal with the time sharing systems and some of the concepts like real-time systems as well as multi-processor environment. Okay, so time shared operating system allows many users to share the computer simultaneously. Since each action or command in a time shared system tends to be short, only a little CPU time is needed for each user. So that means if one operating system is allowed to share with so many users, it will be beneficial, isn't it? How, in what sense it will be beneficial? So if one operating system or one system or the application which is available in one system is shared by so many users, that means you can restrict or you can eradicate the duplication of software, isn't it? I can give one simple example. So in computer lab, if one system has the software like Turbo C, and if there are 30 students who are using Turbo C. Okay, let us take an example like this. So if that is the case, 30 students will be using their own system and they are trying to access that Turbo C from one particular system. If that is the scenario, then definitely it will be beneficial, isn't it? In each and every system, the administrator need not install that particular Turbo C software. So that means if one operating system is shared by, or one platform is shared by so many users, that means we can eradicate the duplication of the software. That is a plus point of this particular concept. And second thing is, so we can ensure that CPU is will not be in idle, isn't it? So each and every user will be trying to access the operating system and they will be having their own slot and they will be trying to run their own softwares or applications, or they will be doing their own work. Okay, so ultimately they will be trying to concentrate on a particular system. So that is one of the example I can give. In the next point, see, a time shared operating system uses CPU scheduling and multi-programming to provide each user with a small portion of time shared computer. Ultimately what they are trying to do, they are going to schedule the CPU ticks. Each and every user will be given with his or her own slot so that they can run their own application on that platform, isn't it? That is the meaning. Okay, so ultimately if you want to visualize, you can visualize like in the center there will be a CPU, and around that CPU there will be so many users and they are trying to access the that particular CPU for their work or for their application to run. You can visualize in that fashion. Okay, each user has at least one separate program in a memory. That means each and every user will be having their own platform. Ultimately they will be trying to access the CPU for the processing. Okay, so that is the meaning. Next point is, a program loaded into memory and executing is commonly referred to as a process. So that means if you are trying to run any application in your operating system or in your PC or computer or anything, it is like anything in the sense, if you are using your phone also, if you are trying to run any application, it is nothing but a process, isn't it? So each and every process has got its own ID. Based on that ID only, the operating system will keep track of that application. Okay, so I don't know how many of you used the Linux platform, but in that platform, if you want to terminate any application or any program using terminal, what you usually do, you are going to use the command called kill, KILL, space followed by the process ID, PID, isn't it? That directly means you are trying to kill that particular process. It is ultimately means that you are trying to close that particular program or application. Okay, each and every application is nothing but running in the operating system is nothing but a process, and each and every process has got its own identification number, and operating system will keep track of that particular application using this PID or process ID. Okay, that is the actual meaning, or that is the actual thing which is happening in the background. Okay, the next one is, time sharing operating system are even more complex than multi-programmed operating systems. In both, several jobs must be kept simultaneously in memory, so the system must have memory management and protection, obviously. So in the multi-programmed operating system, it is nothing but many programs are running in a particular system and it will be in a queue. In the previous session we have discussed, isn't it? We have shown one simple the chart, or what you say, image. In that image one OS will be keep track of rest of the programs or jobs in a queue. So that is nothing but multi-programmed operating system. But when it comes for time sharing operating system, so ultimately memory management and protection has to be taken care. Why? Because if all the users, like say for example there are 10 users and they are trying to access one operating system or one platform, or they are being scheduled with some CPU for their work. If that is the case, each and every application requires memory, isn't it? So if 10 users are trying to access a particular place simultaneously, obviously the memory has to be slotted for all the 10 users. And what about the protection? So protection has to be taken, isn't it? They have to concentrate on the privacy and protection of the data as well, because data is vital. Each and every user has got their own data, their own plan of action, their own privacy. So the data leakage should not happen. So it will be a burden on operating system to take care of memory management as well as protection of user data. So that is the meaning of this particular point. So in the next is nothing but multiprocessor systems. Okay, most systems to date are single processor system, that is they have only one main CPU. Okay, however multiprocessor system are growing in importance. Such systems have more than one processor in a close communication, sharing the computer bus, the clock. So ultimately, see, the meaning is, nowadays this multiprocessor concepts are coming into picture, isn't it? Octa core, quad core, all those concepts. Even though your processor chip is simple, but they are going to separate that particular thing, or they are going to enhance the processing time. If there are multiprocessors, then obviously the performance of that system will be increased. That is the meaning. Okay, so multiprocessor system have three main advantage. So first one is increased throughput. What is increased throughput? Throughput is nothing but the kind of output you are going to get from the system. By increasing the number of processors, we hope that we can get more work done in a less time. Definitely, because if you have more hands, your work will be very easy, and with the short span of time you can perform so many works, isn't it? So that is the meaning. So if you are having multiprocessor in a particular system, so many programs can be run simultaneously in a less time, or so many work can be done in a less time. That is the meaning. So that's why they said that the multiprocessor system will give that particular advantage. Second one is economy of scale. Multiprocessor system can save more money than multiple single processor system, because they can share peripherals, mass storage, and power supplies. What is the meaning? So instead of putting 10 separate systems and giving separate power supply to that 10 systems, or giving separate storage area for that 10 system, or separate keyboard, mouse, and all the required hardwares or peripherals to those 10 separate systems, it is better to implement all those concepts in a particular system which has got best performance, isn't it? If one system can handle the work of 10 systems, then definitely user will go for that particular one system, so that they can need not spend so many money, or they can economically work on that particular system instead of going for many. That is the meaning of economy of scale. Next point is increased reliability. If functions can be distributed properly among several processors, then the failure of one processor will not halt the system, only it slow down, isn't it? So if there are 10 hands and one hand is stuck in some particular work, that means rest of the 9 will continue that particular work, isn't it? So obviously it will never halt down the ongoing process, but it may slow down. Why? Because there will be short of one particular hand or one particular processor, isn't it? So it may slow down the system, but ultimately it will never halt the ongoing process. That is the meaning. Okay, if we have 10 processors and one fails, this is the same example I just have given. So ultimately that means increased reliability. So reliability will be increased if you are going for multiprocessor system. Okay, the next in this particular image you can see symmetric multiprocessing architecture. Okay, that is nothing but, so when you have multiple processors, how actually those processor will try to access the memory, IO, or the storage or any connection. Okay, the most common multiprocessor system now use symmetric multiprocessing, that is nothing but SMP, in which each processor run an identical copy of the operating system, and these copies communicate with one another as needed. So ultimately, what is the meaning? So each and every processor will think that it has got its own operating system, or the same copy of operating system is being installed in each and every processor. So ultimately, because of this, processor think that it has got its own, each and every processor will think that it has got its own space and it has got its own operating system as well as the storage. It's a kind of virtual environment will be set here. Okay, so ultimately, if the identical copy of operating system is being installed in each and every processor, or if each and every processor will access the identical copy of operating system, ultimately the performance will be increased. Why? Because each and every processor has got its own space, and it can run any kind of application based on the requirement. Okay, that is the meaning. Next, SMP means that all processors are peers. No master slave relationship exists between processor. Each processor concurrently runs a copy of the operating system. So there is no concept of master slave relationship. What is master slave relationship? There is nothing like one person is giving the command, so that rest of the processor, or it may be an application or processors trying to follow that particular thing. There is no concept as such. So here each and every operating system will be sit on each and every processor, and each and every processor is a peer. Here there is no concept of master slave relationship. That is the meaning of this particular sentence. So a symmetric multiprocessing architecture uses many processor, and each and every processor has got its own copy of identical operating system will be there for each and every processor, so that it can try to utilize the memory or IO or all the storages for the purpose of application. That is the meaning. Okay, next thing is real-time systems. Okay, so a real-time system is used when rigid time requirements have been placed on the operation of processor or the flow of data. Thus, it is often used as a control device in a dedicated application. So, real time is nothing but, see, in general, if I want to say the concept of real time systems, so the systems will never wait for anything. The meaning is, if there any real-time data, like traffic control system it may be, or air control system, or weather forecasting, so or any live TV footages, isn't it? In those areas all the data is real time. So on the fly it has to take the data, it has to process it, and it has to either it has to send, or it has to store, or it has to display on a monitor, on a screen. So that is the thing. So all those examples can be given for real-time systems. So when the systems deal with the real-time data, or the data which is on the fly or on the go, then those kind of systems can be called as real-time systems. Okay, a real-time system has well-defined fixed time constraint. Processing must be done within a defined constraint, or the system will fail. Definitely. So each and every system has got its own time constraint. There will be a time limit for each and every system, so that within that time it has to process the data, or whatever the data it is being collected by the system, that those data has to be processed within a particular time. That is the meaning. Okay, real time system come in two flavors. One is hard real time system, and another one is soft real time system. A hard real-time system guarantees that critical tasks be completed on time. So if there any important or critical task which has to be completed within a time constraint, such kind of system is called as hard real-time system. Okay, next point is a less restrictive type of real-time system is a soft real-time system, where a critical real-time task gets priority over the other task and retain that priority until it completes. So what is the meaning of this particular sentence? So less restrictive type of real-time system. So example can be, see, telephone switches. There is a concept of telephone switching, isn't it? So based on the priority of calls, they are going to attend it, and sometimes the call may be missed in some cases. So there is no complete restriction on the work. So at that time they can go for soft real-time system, or if the task has to be completed, if it has to be completed mandatorily, then they can go for hard real-time system. Okay, you can visualize a concept like in a hard real-time system, you can take the example of air control system, or some of the systems, see, RTO systems, say, or so CCTV concepts, or live broadcasting things. So all those things can be taken as a example for hard real-time system. But for a soft real system, if the things are not restrictive, or if the work which has to be done is not that mandatorily, then they can go for real time, what you say, soft real time system. Okay, so that is the example I can give for real-time systems. So based on the data, based on the real data, they are going to implement concept of real-time systems in their platform. Okay, so let me wind up the concepts here. So today in this session you have seen one is time shared system and multiprocessor system, as well as real time systems. So if the types of system, if someone is going to ask, then you can list out these three, and you can try to write the actual concepts which are dealt by these three kind of systems. Okay, thanks for watching.